Hello, my name is Fred.
And my name is Frank. This is our user ID.
Dear Director, today we are going to compare the population growth model of Beijing, Jianghua in the next 77 years. And here on the slides is our model for both cities.
Now we are going to discuss the differences and the similarities in factors between these two models a little bit. The two models are both generated based on 20 years of real-world data.
In both models, A represents the rate of change and P0 and B represent the initial population. The initial population of Beijing is larger than Jianghua since it's a larger city.
However, as you can see on the graph, since the model of Beijing is an exponential model and the model for Jinhua is linear, the two A in the model are different.
The A for Jianghua is changing in a constant rate and the A for Beijing is changing in an exponential rate.
Next, let's move into the forecasting part. We use our model to generate the population in 2008 and 2010 and compare it with real-world data. We find for Jinhua's data, the difference between real-world data and the data generated by our model is nearly 0.03, which is negligible.
For the model of Beijing is 0.05, which is also negligible, showing that our model is accurate for short-term prediction. We also predict the population in year 2025, 2030, 2050, and 2100. And find the population will keep on growing forever according to the output of the model.
As shown in the model, the rate of change in the model for Beijing is much higher than in Jinhua. This might be caused by better urban development and job opportunities, which attract migration to Beijing.
In conclusion, in the national cities such as Beijing, the population is going to keep on growing larger and larger, and the government need to increase housing, medicine facility, able to support such a large community.
For Jinhua, a smaller city, the growth rate is still going to grow constantly. The government also needs to build more infrastructures to support the increasing population.
Both models are good for predicting the near future. However, the two models are not good at predicting the long future, since there are unpredicted events such as natural disaster or wars, but they are not computed into this population model. Also, the population cannot grow constantly since there will be a carrying capacity.
Furthermore, in order to figure out the capacity of the formula we created, we did some in-depth research and we find that it can also be useful in another area, such as biology, a topic both of us are interested in.
By changing the influential factor of birth, death, migration, and prediction influence, we can get a population growth formula for animal species.
Thank you.
Thank you.